converting between moles of a compound and moles of a constituent element. So we can look at something like this. Determine the moles of oxygen in 1.4 moles of sulfuric acid, H2SO4. So we can approach this as a dimensional analysis problem, and we're trying to find moles of oxygen, and what we're given is a number of moles of this. 1.4, I can't write today, 1.4 moles of H2SO4. So we need to figure out what the relationship is between moles of oxygen and moles of sulfuric acid. And it is hiding within this formula. In one formula unit, there are 4 oxygens. So that tells us that 1 mole of H2SO4 is equal to 4 moles of oxygen. A lot like 4 leaf clovers or chairs or something. How many legs on a chair? 4 legs is 1 chair. A dozen chairs would have 4 dozen legs, right? Mole is just a unit like a dozen. It's a counting unit. 1 of these has 4 of those. So 1 mole of H2SO4 has 4 moles of oxygen. That's our conversion factor. So we start with 1.4 moles of H2SO4, and we get the units in place. We want moles of oxygen on top and moles of H2SO4 on the bottom. And then the relationship is 1 of these to 4 of those, 1 H2SO4 to 4 moles of oxygen. I should get out my calculator. Where did it? Oh, there it is. 1.4 times 4. 5.6. It's one of those calculations that if you thought about it for a minute, you might be able to do it in your head, but you might get it wrong, so it's not a good idea. 5.6 moles of oxygen. Any questions? Well, going from moles of one thing to moles of another is nice, but what we really want to be able to do is convert between grams of a substance and grams of an element in that substance. We opened this chapter talking about table salt and sodium intake and how much salt could you eat and stay within the recommended limit of sodium. So this is that question again. What mass of sodium chloride, table salt, contains 2.4 grams of sodium, that maximum amount you're supposed to have in a day? We need to remember that the chemical formula gives relationships between moles of substances. Moles of substances, not between grams. This does not tell us that 1 gram of sodium chloride has 1 gram of sodium in it. It tells us that 1 mole of sodium chloride has 1 mole of sodium in it. So looking at the formula, we see that 1 mole of NaCl is equal to 1 mole of sodium. Everybody okay with that? Well, we want to know the mass of sodium chloride. So that would probably be grams. Chemists prefer grams. We want grams of sodium chloride that contains 2.4 grams of sodium. So we've got 2.4 grams of sodium that we're starting with, and we're trying to get from there to grams of sodium chloride. What we have to do is go to moles in the middle. because our relationship between sodium chloride and sodium is on a particulate level. It's looking at the individual particles. And so we need to use this ratio in the middle. So we're going to go from grams of sodium to moles of sodium. Can we do that?
Yes.
Yes, thank you. We just look at the periodic table. We see that 1 mole of sodium weighs 22.99 grams. And then we have this relationship that I just wrote out that'll get us from moles of sodium to moles of sodium chloride. And then we can find the molar mass of sodium chloride and convert from moles of sodium chloride to grams of sodium chloride. Any questions? Writing out the path is the hard part. The rest of it is following the pattern. So in my path here, I've got 3 arrows. I'm going to have 3 conversion factors, or 3 fractions. So 2.4 grams of sodium and 1, 2, 3 grams sodium to moles sodium to moles sodium chloride to grams sodium chloride. Then I'm going to put the units in the denominators so that the ones I want to go away will cancel out. So moles sodium chloride, those will cancel out. Moles of sodium will cancel out. And grams of sodium will cancel out. This ratio in the middle we got from the chemical formula. There is 1 sodium in 1 NaCl unit. So there's 1 mole of sodium in 1 mole of sodium chloride. The relationship between grams and moles is always going to come from the periodic table. We look up sodium. It says 22.99. 1 mole of sodium weighs 22.99 grams. Sodium chloride, we need to look at the formula and the molar masses of each element and add them together. So we've got 1 sodium is 22.99 grams, and 1 mole of chloride is 35.45 grams. $58.44. So 58.44 grams of sodium chloride is equal to 1 mole of sodium chloride. So in this last term then, I've got 1 mole on the bottom, and I've got my molar mass on the top, 58.44 grams. We're taking things that we learned in individual pieces, and we're putting them all together. That's one of the reasons it's important not to fall behind. So I've got this big equation here in the middle, and I'm just going to run it through on my calculator, top to bottom, left to right. 2.4 times 1 divided by 22.99 times 1 divided by 1 times 58.44 divided by 1. And I don't have any room to write my answer. So I'm going to draw an arrow. I'm going to put it up here. How many significant figures should this answer have? 2. We're doing multiplying and dividing, and so we're going to look at the number of sig figs. This one has 2, this one has 4. Those are exact, and this one's 4. So the smallest number of significant figures is 2. I'm going to round my answer, and it's going to be 6.1 grams. 6.1 grams of sodium chloride. So you could eat 6.1 grams of sodium chloride, and if you didn't eat anything else that contains sodium, you'd be within your limit of sodium intake. That's a lot of table salt to eat. Any questions?
How did you get from 58.44 to 6.1?
How did I get from 58.44 to 6.1? I started over here. 2.4 divided by this.
No, the how you rounded it. I would have thought that would be.
No, this is not 58.44 rounded. Yeah, it's the result of the calculation. Any other questions? See, this silence either means you all get it, or you're all so confused you can't even come up with a question. I don't know which it is, but I can't make you talk. Let's do another one. Determine the mass of oxygen in a 5.8 gram sample of sodium hydrogen carbonate. And I gave you the formula there. So this is sodium hydrogen carbonate. So let's start with thinking in terms of dimensional analysis. So what information am I starting with? 5.8 grams of the whole thing, right? NaHCO3. And I want to find what? Mass of oxygen, so grams of O. Can I go directly from grams of one compound to grams of an element? I can't. So I need to go through moles in the middle. So I'm going to change this to moles, and I'm going to run out of room. Moles of sodium hydrogen carbonate. And from there I can go to moles of oxygen. And from there I can go to grams of oxygen. Does that make sense? The formula gives us relationships between the individual particles. It doesn't give us relationships between the masses. Mass is useful because we can measure it on a balance. We can't count atoms and molecules because they're too small. Once we have the path in place, we can write out the equation. Put the units in first and then take care of the numbers. So 5.8 grams of that. And on this next line is going to be moles of sodium hydrogen carbonate. Trying out a new stylus here, and it's not behaving very well. And then next is moles of oxygen. And next will be grams of oxygen. We take this first unit and it becomes the denominator in the second fraction. Because I want those units to cancel out. Moles of sodium hydrogen carbonate. And I know some of you don't like to write the formulas because it gets tedious and long. I agree with you, it's tedious and long. But if you don't write out the formulas, you're probably going to get the answer wrong. And if you get enough answers wrong, you end up taking my class over again. And that's even more tedious, right? You don't want to do that. Not that I don't like you, but I'd like you to move on. All the units in place. Now we look for numbers. Units first, then numbers. The units tell us where to put the numbers. So this relationship, moles of oxygen to moles of sodium hydrogen carbonate, we just look at the chemical formula. In one of these units, there are 3 oxygens. So 1 mole of sodium hydrogen carbonate has 3 moles of oxygen. I always like to start with the easy ones first, and I think that middle one is the easiest. I think this is the next easiest. This is an element. We just look at the periodic table. 1 mole of oxygen weighs 16 grams. It's just written on the periodic table. This first one here, that's the one that's a little trickier, because here we have to do some adding. We have to calculate the molar mass. We've got the formula. There's 1 sodium, so we take the molar mass of sodium. And how many hydrogens? 1. So 1.008 is the mass of 1 mole of hydrogen. How many carbons? 1. 12.01 grams, it's 1 mole of carbon, plus how many oxygens? 3. So we need 3 times the mass of a mole of oxygen, getting smaller and smaller. And then we add all that up. 22.99 plus 1 point, whoops, that wasn't a plus. Plus 1.008 plus 12.01 plus 3 times 16 equals. My calculator says 84.008 grams is equal to 1 mole. I've been doing it with molar masses containing 4 sig figs, so this would have 4 sig figs. But I don't want to round it off just yet. It's best to not round anything until you get to the end and you've got your final answer. So now I'm going to try to squeeze this in here, 84.008. Any questions? I've got my equation all completed. Now I'm just going to multiply and divide. If you want a number up here, it's going to be a 1. So 5.8 divided by 84.008 times 3 times 16. And this one should also have 3 significant figures because the number I started with has, I'm sorry, not 3, 2 significant figures, 2 sig figs. This is 2 sig figs. This has 4. I didn't indicate that. This one has 4. The one in the middle is exact. This one has 4. So this is going to be 3.3 grams of oxygen. Any questions?